Thompson Couplings business is a design house. We've got the rights to the patent for the Thompson coupling, which is the revolutionary constant velocity shaft coupling. The design of the coupling revolves around two rotating shafts where we're trying to transmit power from an input to an output at an angle. And there's no other constant velocity coupling that can do that as efficiently and as durably as this device here today. Right through industry, we've got shaft couplings that are used in power stations, in windmills, in helicopters. One of the biggest problems that we've got in a helicopter today is that horrible coupling up the top of the rotor head. With the Thompson coupling, we can eliminate the vibration problem, we can still take the axial load of the weight of the helicopter, and we can make the whole travel a better experience and a lot safer as well. So when the challenge came for us to design the new Thompson coupling, it was basically straightforward. We knew that we had to use Inventor. Probably the biggest business benefit that we see in digital prototyping is time. The amount of time we can save in generating and producing the coupling is probably 75% of what we would traditionally do in the old world, where we had to hog it out of steel, draw it up in 2D. It's just the time benefit is huge saving to us. We use the digital prototyping in our design by converting the solid model of Inventor. After we've done all our finite element analysis, we've proved that all the loads are satisfactory. We can then export all the files to STL format down to our workshop, and they can quite affordably and economically produce all of these components at a fraction of the cost of making it out of steel. Probably the biggest benefit that we've seen with Inventor is the integration of the finite element analysis or FEA software that's built into it. We can very simply extract the data from the solid model into the Inventor, and using the FEA tools we can calculate the stress, we can calculate the deflection, we can even calculate the velocity and acceleration profiles of each of the components within the Thompson coupling. And we use the Inventor model to rotate the components, to check for interlashing problems with fits and clearances. And we're also able to dynamically simulate that coupling as it rotates through its 20 degrees of operation. We actually use the stress analysis and motion simulating tools within the Inventor software as a key feature of this design. We are actually building a coupling right now that is capable of withstanding 2,000 horsepower. We cannot physically build that and test it in situ. We have to rely on the built-in FEA package to try and quantify all those loads. We probably don't do any manual calculations anymore at all. All our shafts are automatically calculated using FEA. All our journal bearings, again, equally calculated through the FEA package. So it's really in my opinion, it's the best tool that's within the Inventor. It's that integration of FEA that we really love. As our business grows, the digital software will enable our engineers to pick up all the tools that Inventor utilises, and because it is affordable, we can grow at an economic pace and not blow our budget. I genuinely trust Autodesk solutions because I know it works. I've grown up with it in the last 20 odd years. I've gone from AutoCAD 2.5 right through to the current Inventor software, and over that time I've proved it works.